Okay, welcome to the second lesson of Chapter 4. This one is entitled Angles of Triangles. The previous lesson we talked about types of triangles. We're specifically focusing on the angles themselves. And if you look at the very top here in the cloud here under objectives, it says that our objectives today, sorry, I'm trying to get my pen back where I need it. Try this again. Okay, so our objectives for today are to apply the triangle sum theorem and to also apply the exterior angle theorem. So before we go there, let's answer some questions. Do you know how many degrees are in a triangle? And does that amount of degrees apply to any triangle, whether it's obtuse or it's right or it's acute or equiangular? Does that apply? Hopefully your answer to that are twofold. One is that they all add up to 180. And you should know from yesterday's lesson that yes, it does apply to all triangles. So therefore, this is something we know. There is a name for this property. It's called the triangle sum theorem. This is one of the first theorems that we have learned. A theorem is basically a rule that has been proven to be true, okay? And the good thing about having theorems that have already been established, we don't have to prove that triangles have 180 degrees. We can use that fact to solve problems. We don't have to prove that they're 180 degrees, then solve problems. So that's good to know. So this particular triangle is just saying, it's just a demonstration or a visual aid of what the triangle theorem says. It says if you have a triangle ABC, it doesn't matter what the angles, you don't have to know what each angle is to know what it adds up to. It's irrelevant because no matter what triangle you're able to draw, they all add up to 180 degrees. So that's the answer to that question. Can you have two right angles in a triangle? Yes or no? So pause the video for a second and decide what your answer is. And then once you've got an answer, replay the video. Okay, the answer you should have gotten is no, because if you have two 90-degree angles, that already adds up to 180, and we know that a triangle has 3 angles in it. So if 2 of them are already taking up the 180 degrees, there's no way you can have 2 right triangles being in one triangle. You can't draw it. So the answer is no. Okay, so as I mentioned, we were talking about different kinds we're focusing on the angles, and words you may not have heard yet too much is the word interior and exterior. So basically, in this picture here, under interior, exterior angles portion here, you're going to see that angles 1, 2, and 3 are interior angles because they're inside the triangle, and angle 4 is outside of this triangle. So here's your triangle. So since angle 4 is outside, it's called an exterior triangle. So, however, even though 1, 2, and 3 are all interior interior angles, there is a specific name for some of these interior angles. So I'm going to circle the ones I mean. This one, angle 1, and angle 3 are called remote interior angles because they are not right next to an exterior angle. So angle 2 is an interior angle, but because it's next to angle 4, you can see how they're side by side here, angle 2 cannot be a remote interior angle. It's just a plain old interior angle. Remote, I like to think of remote as being like, when you hear like a show like Entertainment Tonight, talk about some Hollywood stars that went and had a wedding in a remote location. That means that they went somewhere that they weren't near a lot of people. They were in an area where there wasn't really other people around to bother them. So I kind of think of it that way. The remote interior angles are the ones that don't want to be near the exterior. They want to be furthest away possible. So that's why in this case, 1 and 3 are your remote interior angles, and then angle 4 is the only one that's your exterior angle. So up here I'll go and clarify that 1, 2, and 3 are interior angles, angle 4 is an exterior angle, but angles 1 and 3 are special interior angles. They are remote interior angles. And last but not least, I mentioned at the top that we had the triangle sum theorem to learn, and then also the exterior angle theorem, which is 4.2. What it says is that angles 1 and 3, for example, in the picture above, which are your remote interior angles, are always equal to your exterior angles. So you could rewrite this theorem and say in your mind that the sum of the remote interior angles are equal to the exterior angle. So just keep that in mind. And also, just another note, 2 and 4, if you look up here, are also a linear pair if you think about it. Because these two angles are formed, so I'm going to erase this so you can see. If you trace this line, there's this side here. This side is an extension of this triangle ABC, and if you can see, this is kind of, BC is kind of like a ray coming out of that line. And remember we said if you had angles formed from a line, they're called a linear pair. So that's why 2 and 4 are a linear pair also. Just kind of bringing up some old vocabulary that we always need to have at the top of our minds. Okay, so let's move on and go to number 1. Find the measures of each numbered angle. Okay, so look at number 1, and what I would like you to do is pause the video and see if you can figure out what the answer is, and then as soon as you do, come back. Okay, the answer you should have gotten is 58 degrees, because we know that a triangle has 180 degrees. So basically you just need to take 180 and subtract 63, and then also subtract 59, okay, and you should get 58. Okay, so that's the math involved there. Another way students like to do it is they add 63 and 59 together, get that number, and subtract that from 180. Whatever works best for you, do that. All right, the next one we're going to do on page 250 is number 2. So this one's definitely more complicated, and they want us to find the measures of each numbered angle. Okay, so we've got several. We've got 3, in fact, that we need to find. So let's work on that. So I'm going to enlarge this a little bit, and let's see if I can enlarge this, and let's focus on number 1. Okay, so number 1 is part of this right triangle here on the top, and as you can see, they give us the 90-degree angle right here. They also give us this angle right here is 48. So this is going to be pretty simple, just like number 1. You're just going to take 180, subtract 48, subtract 90, and that'll let you know how much angle 1 needs to be. So your measurement of angle 1 is equal to 42. Now, angle 2, you'll notice we're going to have to use a little bit of prior knowledge here. The thing that stands out to me is these parallel line symbols. That is something that is really going to help me find angles 2 and 3, okay? So, for example, if you think about this as being two parallel lines, okay, this line right here is a transversal, and these are alternate interior angles, and we have learned in the past that alternate interior angles are congruent. So we can already go ahead and say measurement of angle 2 is equal to 39 degrees. Okay, and so if we know this is 39 degrees and we know this is 90, we can easily find out that this one is, this one meaning angle 3, is simply finding out what 180 minus 90 minus 39 is, which is 51 degrees. So that's your answer for angle 3 is 51 degrees. All right, let's move on to number 3. All right, so this is an example of a picture of, we've got remote interior angles. We don't know this second one there because that's angle 2 and we don't know how many degrees it is because there's no degree mark there. But we have 2 remote interior angles and 1 exterior angle. Now, there is a way to do this without doing this theorem, to be honest, because if you think about it, we know these are a linear pair, right? So if you take 180 minus 112, you'll figure out this angle right here. And then you can subtract 32 from that, add that angle you just found, add 32, subtract that from 180 to find angle 2. But that's a lot of steps, and that's not utilizing what we're supposed to be learning in this lesson. So please do not go back to older methods that are less efficient. Use the new rules. If that is the purpose of this lesson, is to do this more efficiently. And so this is what I want you to do instead. So when you're doing your classwork on your own, I want you to use the exterior angle theorem, which says the sum, and I think it's very helpful to write this out, the sum of the remote interior angles, and you can, just write it in abbreviations. It doesn't have to be long drawn out. Just say it to yourself in your mind. The sum of the remote interior angles is equal to the exterior angle, right? So if that's true, that means angle 32 degrees plus angle 2 equals 112. So you can see real quickly, all we got to do is subtract 32 from 112, and we've got angle 2 just like that. So please do not do it in 2 steps, just utilizing the fact that the angles in a triangle add up to 180 and that a linear pair adds up to 180. So I'm telling you, you need to use the exterior angle theorem, okay? Because if you don't utilize it during practice on homework or classwork time, if I ask you to specifically use that theorem on a test, you won't know what I'm talking about. So get practice now. Okay, let's move on to 4. So they want us to find MPQ, which would be this angle right here. Okay, so again, we are going to use our new knowledge, which is the sum of the remote interior angles are equal to the exterior angle. Well, they give us the 2 remote interior angles right here. Now, if they gave us this one right here, we wouldn't want that. That's not a remote interior angle. It's just a regular old interior angle, which is useless for what we're trying to do right now. But according to this, we said this plus this equals that, right? So I'm just going to simply add 56 plus 45 because the sum of the interior angles is equal to the exterior angle. So this comes out to 101 degrees. So that means this angle right here is 101 degrees. So again, such a useful theorem, less chance of making mistakes because you're just doing one calculation versus 2 or 3 to get the same result. Okay. Now let's work on going to the next set of problems, which is 5 through 8. So when we start 5 through 8, let me get my zoom in. And so what we're going to do is they tell us that angle 1 is at 102, okay? So I'm going to mark that. And then it also tells us that angle 3 is 53. And so I put in that information. And so number 5, they want us to find angle 4, which is up here. Okay. Okay, so based on this information, you might think, oh, wow, okay. I don't know how I'm going to do that, but what you want to do is figure out what are my remote interior angles and which are my exterior angles, and it's going to change depending what you're looking at. So I'm going to draw the triangle that the two interior angles appear to be in, which are right here, okay? And then this is an exterior angle to that triangle. So as you can see, angles 1 and 2 are a linear pair and they're adjacent to each other. But if you look at angles 3 and 4, those are our remote interior angles, and we're trying to find angle 4. So we're just going to use our little rule we just learned. The sum of the remote interior angles are equal to the exterior angle. Okay, so if I add angle 4 plus 53 degrees, I can set it equal to 102 degrees and solve for angle 4. So that's what I'm going to do back over here. So I'm going to say angle 4 plus 53 degrees is equal to the exterior angle, which is 102 degrees. So I wrote that angle 4 and angle 53 added together, which are my remote interior angles. Remember, our exterior angle theorem says the sum of the remote interior angles is equal to the exterior angle. So now all I got to do is subtract 53 from 102, and angle 4 is going to be equal to 49 degrees. Just a reminder, please pause this video in between and try to work ahead of me on your own. And then of course if you get stuck, come over here, but that's really going to be your best bet to understanding, is if you actually struggle a little bit and figure out where your problem areas are, and then I can help you right away because you're already working. If you just passively look at what I'm doing and not actually try it by pausing the video, when you get to doing the problems on your own, you're not going to have a clue because you've not even figured out what you don't understand yet. So pause the video and do number 6 on your own as much as possible. Okay, so what I've done is I've just refocused what I'm trying to find. I'm trying to find angle 6, and angle 6 is this remote interior, it is an exterior angle of this triangle that I highlighted in red. And if you'll notice, they're asking about angle 6, but they gave us angle 3, which was 53, and remember I told you earlier that these are a linear pair. Because they're side by side and they're formed along this line down here. So all we got to do is take 180 minus 53 and you can get the answer for 6, angle 6, which happens to be number 6. So 180. It's real important for you guys to really write out the calculation we did. Because I find students sometimes, they'll just write the answers, and then when they try to do these themselves, I'll say, well, go look back at the work we did, and they didn't write it down. So there's nothing to refer back to. So get in the habit of doing that. It's often the best way to sometimes figure out how to do things is knowing, even if you don't understand it in class, writing the work down so you have something to look back, you can hopefully have time outside of class to think about it and understand it. Okay, so now we're going to try and find angle 2. So I'm going back over here. And again, remember they told us at the beginning, I'm going to get this extraneous stuff we don't necessarily need. And now I'm going to do angle 2, which we're trying to find this one. And if you remember in the information they gave us, they told this was 102. So again, pause the video, see if you can figure it out. Okay, again, you'll see from the picture that angles 1 and 2 are a linear pair because they're side by side and they're formed from a line. So we're just simply going to take 102 from 180 since they're a linear pair and just figure it out. So it's going to be 78 degrees. All right, and then the last one of this section is 8. And so I'm going to again erase what we don't need, find 8, which is, I'm sorry, it's number 8. I'm looking for angle 5. Okay, so angle 5 is up here. Trying to find that, and if you remember, probably the easiest thing is we found in number 5 that this was 102, right? Number 5, angle 4 was 102. I'm sorry, it was 49. I read the wrong thing. That would have really messed us up if I didn't catch that. Sorry, the answer to number 5 was 49, and so that was angle 4. So again, if you'll notice, these are a linear pair. They're along this line right here, and we all know, just like our protractor goes 180 degrees, our lines are 180 degrees. So since we know angle 4 already is 49 because we did number 5, we're just going to utilize that information. So there's more than one way to do it, so that's not the only way. And we're going to get 131. Okay, degrees. So that concludes that section. We're going to do these. Again, we're finding each measure, and number 1 you should be able to get yourself, so pause the video and check back with me to get the answer. Okay, you should have gotten 61 degrees because they tell you that this triangle right here has 29 degrees, 90 degrees, and so you've already got 29 and 90 of the 180 used up. So all you got to do is take 180 and subtract 90 and subtract 29, okay? That's how you're going to get the 61. Then moving on to, I'm going to erase that work there because hopefully you got that one pretty easily. So if you'll pause the video, I'd like you to try number 3 on your own. Okay, welcome back. Hopefully you found out that these are a linear pair. So we could find angle 2 right here, real easy. Or, remember I said, to find angle 3, there's a more direct way to do that. But because we're also going to have to find angle 2, in this case, you know, you could find angle 2 before 3 and do it that way, but I prefer that you find angle 3 first before jumping to 11 to find angle 2, and I want you to use, this is true, this is a linear pair, but like I said, we're not trying to find 2 right now. So don't jump the gun, please, on that. Let's focus on 3. So if we have 3 is what we're trying to find on number 10, and you'll notice angle 3 is part of this triangle right here. And we learned a theorem today that the sum of the remote interior angles, which would be angle 3 right here and 17, added together equal this exterior angle. And you're like, whoa, that's an exterior angle. Yes, it is, because here's your big triangle I outlined already, and if you extend one of the sides, that becomes an exterior angle of this triangle. So it's really easy to see that the answer for angle 3 is 12, because 12 plus 17 equals 29. So our answer for angle 3 is going to be 12 degrees. All right, and then now we can skip on down to finding angle 2. So I'm going to erase this stuff we don't need. Okay, and you could find angle 2 one of two ways. You can find angle 2, now that we know this is 12 degrees, you could take 180 and subtract 17 and 12 from it to get the answer, which would work. Or we know that this is a linear pair, so we could just do 180 minus 29. You'll get the same answer, because if you think about it, 12 plus 17 is 29. So if you did the triangle sum theorem and said, okay, 180 minus 12 minus 17, I mean, same thing as subtracting 29. So I don't know. You can treat this as a linear pair or as one of the 3 angles in a triangle that add up to 180. Totally up to you on that one. Either one is a good method. Okay. So either way, you subtract those, you get 151 degrees. All right, so that concludes that section. There's one I want to do with you, because on the problems that you're going to do by yourself, there's a harder one that's not in this section. So we're going to jump on over to 22. So I wanted to do a harder one with you. It's not that hard, it's just it's got expressions instead of just numbers, and we've not had to deal with that yet. So let's deal with it. The directions at the top say to find each measure. So that's what we're going to do. And the measure they specifically want us to find is JKL. So JKL is this angle right there. You'll notice JKL is equal to 2x minus 11 degrees. Well, we do not have x, so we're going to have to solve for x so we can figure out what angle K is. All right, so let's look at what we have here. We have an exterior angle, and we have this is a remote interior angle, and so is this. Remember, the third interior angle is right here, but we don't want to even care about that one, so I'm gonna undo that, because it does not help us. It's not part of our exterior angle theorem. Our exterior angle theorem says the 2 remote interior angles added together equal the exterior angle. So the 100 degrees is our exterior angle. The remote interior angles are, that we have in this figure is angle K and angle J right there. So we're simply going to add angle J and K together to get this exterior angle. So let's do the math on that. I'm going to scoot on over here to the side. So we're going to say 2x plus 27, that's our first remote interior angle, plus our second remote interior angle, which is 2x minus 11. I'm going to erase that and do it a little lower so that it fits. Okay, so again, I'm going to take my first remote interior angle, which is 2x minus 11 degrees, add to it, remember it's the sum of the remote interior angles is equal to the exterior angle. So I'm going to add my 2 remote interior angles, which are these expressions, and they are added together are going to equal 100, because that's the value of my exterior angle. Now, if my exterior angle was like 100 plus x, it wouldn't matter. I would still set it the two sums, or the true sum up the 2 remote interior angles and set them equal to the exterior angle. Whatever it is, whether it's a number or an expression, you're just going to follow that theorem and then substitute in what they give you. Okay, and then go from there. Just trust the math. So the first thing we got to do is combine like terms on this left side of the equal sign. So my 2x and 2x become a 4x. My negative 11 and 27 are going to be 16. And then we're just going to do our math. We'll just subtract 16 from both sides. and divide by 4. And I'm going to check that real quick and make sure I do it right. So we're going to take 100 minus 16 divided by 4. So we're going to get x equals 21. But if you look back at the question, it doesn't ask for x. And it asks for angle JKL. Well, angle JKL is 2x minus 11. So I'm just going to continue over here. So angle JKL equals 2x minus 11. We did find what x was. It's 21. So then you're just going to do the math there, which will end up being 42 minus 11, and your answer is 31. So JKL, angle JKL is 31 degrees. Okay, that concludes what I'm doing with you in class. And please, if you start doing the problems on your own, please be checking your answers in the back, section by section, before moving on. And if there's any you don't understand, try and work some of the problems I did with you on this video by pausing the video and trying it on your own. And maybe some of the things that you get stuck on while working on it will be similar to what you're struggling with when you're doing it on your own. So just rework the classwork problems with me by pausing the video and trying them for yourself and not giving up too soon. Stare at it for a while. Don't just give up and start the video right away. It's important that you work through that struggle, no matter how long it takes. Don't just take the shortcut and start the video. And it's a totally different way of thinking. When you struggle with it yourself, that's when you start to understand it versus someone just showing you how to do it. So please do that. It'll just make you a better math student overall, and it'll make math easier for you in the future. All right, have a good rest of the day.